Alright, so in this video over here, we'll be talking about how to find the equation of some sort of tangent to any curve. So we're looking at the blue curve over here, and our objective is to find the gradient of, well, not the gradient, the equation of this red line, the tangent at this black point. So what we mean by tangent is that it smoothly just goes across the blue curve, and it uses the exact same gradient, or the instantaneous gradient of the blue curve. So a few things you need for the equation of a straight line. So two things you need are, very specifically, you need some sort of gradient, okay? So if you want to find the gradient of tangent, you simply sub in the value of x into your gradient function f dash. Now, of course, if you need to find the gradient of a perpendicular line, then what you're going to need to do is you need to use this relationship between the gradient of a perpendicular line and a tangent line. Because if I was to draw a line that's perpendicular to this red line here, so as I can, it's got some 90-degree angle here, then the relationship between the red line's gradient and the green line's gradient is that it's the negative reciprocal of the tangent gradient. Now, the other thing you need to find the gradient of a straight line, the equation of a straight line, is to find the coordinate. So these are the two things that you need to find the equation, and after that you can plug it all in or put it all together, I should say, by using this over here. So you can either use two methods here. One, you can use y minus y1 equal to mx minus x1. Now this method over here assumes that you have a point, so the point over here is at x1 comma y1, and you get it from the previous step over here, or use y is equal to mx plus c and sub in your coordinate x1 and y1 into here to solve for c. All of that should be quite elementary at this point, but we'll use both methods in this video just to demonstrate how we can do this. Okay, so in our first example, we have some sort of cubic function here, and we want to find the equation of tangent at x equals to -1. So first step over here is we need to find f dash. Okay, because this function over here tells us the gradient for any x value that you sub in. So for the derivative of a polynomial, all we do is keep the negative in front because it starts with a negative, bring the index down so you get 3 x, and you want to subtract the index by 1, so the 3 turns into a 2. Now for the next term we have -3 in front. It's going to index up 2, so we need to multiply by 2. X, we keep the x there, and the 2 turns into a 1. And of course for the constant, this one just stays as 0. Okay, so our derivative over here is going to be -3x squared minus 6x. Okay, so we want to find the equation of tangent at x equals -1. So you need both the gradient and the coordinates of that point. So these are the two things that we need. Now we're going to work with the gradient first. So this one over here, we're going to say f dash where x is equal to -1. So plug this in, what you're going to end up with is -3 times -1 squared, -3, minus 6 times -1, so we have plus 6. This is equal to 3. Okay. Next up is we're going to find the coordinate at x equals to -1. So to find the coordinate, or in other words to find the y coordinate, simply sub in x equals -1 into our original function f. So what we have is -x cubed, where x is now -1, so you can have +1 here. Just put a positive sign there, just to be sure. Minus 3x squared, so x squared, or -1 squared is 1, minus 3, plus 4. This is 2. Okay. So you know over here that your point is going to be -1, 2. So we have a straight line which passes through -1, 2 and has a gradient of 3. So use this and use this coordinate over here. Okay, scroll down a bit, and in this case over here we're going to use y minus y1 equal to m, let's redo that, m x minus x1. Okay, and so if we plug all of this in, then we're going to have y minus 2 equal to the m value here is the gradient of the tangent, so we're going to use 3, x minus x1, or the x coordinate of our point, which is -1. So what we really have is +1 over there. Okay, so the rule over here, or the equation of the line, is going to be 3x. Now expanding this bracket over here, we have 3 times +1. So we have 3, add the 2 as well, and we get 5. So for a perpendicular line, the process is almost identical, except there's this extra step that you need to take after finding the gradient function. Now, we're just going to recycle a bit of information here, because we are using the same function. Now we know that f dash, our gradient function, is equal to, just have a quick check at what it was, -3x squared minus 6x. And instead, we want to find the gradient of the perpendicular line at x equals to -3. So you do actually need to find out the gradient of the tangent first, and use that to help you out. So when we do this, I'm going to get -3 squared, which is 9. 9 times -3 is -27. -3 times -6 is 18. So we get -9. Now remember that this is not the gradient of this perpendicular line. This is tangent, gradient of our tangent. What we want to find is something else, gradient of the perpendicular line. So we say NP is equal to the negative reciprocal of our tangent gradient. This is equal to 1/9. Okay, and of course we need our point as well. So we're going to sub in -3 again into the original function to find out the point. Now the original function is, let me just check my notes, it is -x cubed, so we have 27 minus, let's see, minus 27 plus 4. So if you've got the rule, just refer to the notes above, but over here it's simply a matter of substitution. So these two will give you 0, so our coordinate over here is going to be at -3, 4. Okay, so we have everything we need now. The only things you need for a straight line, or equation of a straight line, is the gradient and the point, and just one point that passes through. So over here, we're going to try out the y is equal to mx plus c method. Won't give you the same result, it's just a matter of preference really. So in this case over here, what we're going to be doing is not writing y, we're going to be subbing in -3 and 4 into y and x. So just to be clear, what we're doing here is the 4 will go into the y, and the -3, so just grab a different color, -3 go into x. Okay, we have 4 equal to m is 1/9 in this case, -3 plus plus c. Okay, and over here, what we're doing is we're just solving for c, so we know what the constant term is in our equation. So c is equal to 4 plus 3 on 9, 1/3, which is equal to 13 and 3. So in the end, y is going to equal to 109x. So this represents our mx plus c, and the c value is 13 on 3.